Ever get frustrated with like how slow and expensive sending money can be,
Mm,
especially like internationally? It's like,
mm.
haven't we moved past this yet?
Right. You'd think so. And that's a big part of what cryptocurrency is trying to solve, systems that are faster, cheaper, more transparent, you know?
Which is what has me so curious about the Ripple protocol. They're making some bold claims about being the future of finance, so we're doing a deep dive into their white paper, the Ripple protocol consensus algorithm.
Uh-huh.
But don't worry, we'll decode all the tech stuff together.
Absolutely. We'll break it down how Ripple actually works behind the scenes to make sure your transactions are secure and reliable.
Okay, so let's start with the basics then. When we say distributed payment system,
Yeah.
what do we even mean?
Basically. Moving away from that old model where banks are the middleman, instead, transactions are verified and recorded by a whole network of computers spread out all over the world.
So instead of trusting one bank, we're trusting this whole network. But how does that make things more secure?
That's where this idea of consensus comes in. And it's a big deal for what makes Ripple different. So imagine you're trying to buy something online, right? You've only got enough money for one purchase, but you try to buy two things at the exact same time.
Oh, sneaky.
Right, that's the double spend problem, regular system. The bank would catch that, only process one transaction. But in a decentralized system, no central authority. So there needs to be a way to make sure everyone agrees on which transactions are legit. That's what the Ripple Protocol Consensus Algorithm, or RPCA for short, that's what it's designed to do.
So it's like checks and balances, but instead of a bank, it's all math and algorithms.
That's fascinating, but also sounds like it could get real complicated.
It can be, but the core, the RPCA boils down to three main things: correctness, agreement, and utility. Correctness just means every transaction is legit, preventing stuff like that double spending we talked about.
Makes sense. What about agreement then?
So agreement means everyone on the network, all those computers, they have to come to a consensus on which transactions actually went through
Yeah.
and in what order. So it's like creating the single unified history of transactions everyone agrees on, and that prevents confusion and fraud and all that.
Okay, so we've got the system making sure transactions are legit, everyone's on the same page. What about utility? That's
Yeah.
what makes this actually useful for, regular people like me. It can't just be e-secure, got to be practical too. Utility is about speed, efficiency. Ripple's known for near instant transaction times, super low fees, which is a big deal compared to some other cryptos that can, well, take ages.
Okay, so we're talking faster, cheaper, more secure. I'm starting to see why people are excited about this.
Yeah.
But how does it actually work in practice? How does Ripple pull off this consensus without someone in charge calling the shots?
That's where it gets really interesting. Ripple uses this system called a unique node list, or UNL, and it's a big part of what makes them stand out. We'll get into that right after the break.
All right, so before the break, we were getting into how Ripple actually pulls off this whole consensus thing without needing a bank or anybody in charge. And you mentioned something called a unique node list, UNL. Sounds kind of like a VIP list for crypto.
Haha, I like that. Yeah, you can think of it that way. So the UNL, it's basically a list of these trusted validators that you choose. You rely on them to check transactions, make sure everything's good. It's almost like curating your own news feed online. But instead of news sources, you're picking who you trust to tell you what transactions are happening on the Ripple network.
So instead of trusting every single computer on the whole network, I get to pick, I don't know, like a smaller group, ones I think are going to give me the right info.
Exactly. And that's a big part of why Ripple is both secure and decentralized. See, some other cryptos, you got to trust that the majority of the whole network is honest, right? But Ripple's different. You're just relying on the majority of your UNL, that list you handpicked.
Okay, yeah, that makes sense. So if I'm careful about who I put on my UNL, people with good reputations and all that, I can feel more confident about those transactions I'm seeing. But let's say, just hypothetically, one or two of the validators on my list turn out to be, I don't know, bad actors. Could they mess things up for everybody else?
That's a really good question. And it leads into one of the coolest parts of Ripple, the 80% threshold. So for any transaction to go through, be considered valid, at least 80% of the validators on your UNL got to agree. Which means that even if a couple bad actors slip through, they can't really do that much damage as long as the majority of your UNL is on the up and up.
Oh, so it's like a safety net built right in. Even if I accidentally trust a few bad apples, the whole system is, I don't know, kind of protected. But how does that actually work with the 80% thing? Is it like thousands of computers all voting on every single transaction every time?
And that's where consensus rounds come in. Picture this. Instead of all the validators just shouting their answers at once, they take turns, they propose sets of transactions, then vote on them, but it's all structured, organized.
More organized. So I'm getting like group project vibes here, where everybody gets a chance to chime in, review the work before it's final.
Exactly. Each round's like a check-in point. Validators compare what they've got, smooth out any differences, and finally, they agree on which transactions are legit, ready to be added to the blockchain.
Okay, yeah. I think the bigger picture is starting to come together now. We've got the UNLs, this 80% rule,
Yeah.
these consensus rounds, all working together. Makes it both secure and efficient, right?
Yep.
But the white paper, it also mentioned something called the Byzantine Generals Problem. And honestly, that sounds a little intimidating. What in the world is that all about? Okay, so we were just talking about that Byzantine Generals Problem. Is this where things get, I don't know, real intense, like some kind of digital Game of Thrones situation?
Uh-huh, not quite. It sounds dramatic, yeah, but it's actually this classic problem in computer science. It's all about how do you get consensus when you can't be 100% sure everybody's being honest, especially in these systems spread out everywhere.
So, like, some of those generals are secretly trying to, like, mess up the whole plan, sabotage?
Exactly, that's the idea. Can these generals, some might be traitors, right? Can they all agree on a plan even if they're only talking through messengers who could be, I don't know, intercepted or even tricked into delivering the wrong message?
And how does that apply to, like, Ripple itself? Are we saying some of the computers on the network might be going rogue?
It's more like acknowledging that any system this big, this spread out, there's always a chance some actors aren't going to play by the rules. Could be intentional, could be technical glitches, who knows?
Okay, so then how does Ripple actually deal with these potential traders and still make sure everyone agrees on which transactions are good to go?
And that is where the UNL, the 80% rule, those consensus rounds, it all comes together. By being choosy with your UNL and needing that supermajority to agree on anything, it makes it really hard for a few bad actors to actually disrupt things.
So even if there are a few of these, what was it, Byzantine generals lurking around, they can't do too much damage if the majority of my UNL is, honest and doing their thing. That's good to know. But you mentioned earlier how Ripple transactions are supposed to be crazy fast, like seconds.
Yeah.
How is that even possible with all this checking and double checking going on?
See, that's another clever part of their system. They've got these really smart features built in to keep things speedy without sacrificing security. One example is something called the 2-second rule.
2-second rule, like don't let your cryptocurrency touch the floor. What does that even mean here?
Haha, good one. No, in this case, it means each validator, they've only got a tiny window, 2 seconds, to propose their transactions to the network. Keeps everything moving. Nobody can hold up the whole process.
Ugh, like a built-in deadline. Love it. Anything else Ripple's got up their sleeve to make it even faster?
Oh, there's more. The RPCA, it's got ways to spot and even penalize validators who are always slowing things down or trying to mess up the consensus. Remember those rounds we talked about? Well, if someone's always voting no on good transactions or trying to push bad ones through, they get flagged. Their influence goes down.
Like that one person in the group project who's always going to make things difficult. Eventually, everyone else just tunes them out.
Precisely. So it weeds out the bad actors. The system runs smoothly for everyone who's playing fair.
This is making so much more sense now.
Yeah.
We went from like zero to actually understanding how Ripple keeps things safe, fast, and efficient, all thanks to this deep dive into their white paper.
Absolutely. There's always more to learn, of course, but this gives you a great foundation, how Ripple offers something really different from traditional finance.
For sure. And you know what? That white paper, DID mentioned something about network splits, which honestly sounds like a whole other fascinating challenge, but we'll have to save that deep dive for another time.